Welcome everyone to our webinar on Talk to Your Network Data with ChatBot. I'm Milan, a solution architect from IP Fabric, and I'm excited to guide you through this fascinating intersection of network data and conversational AI. Before diving in, I'd like to highlight a crucial point. Today's exploration of cutting-edge tools like conversational AI wouldn't be possible without the invaluable data provided by the IP Fabric platform. While alternative data sources exist, IP Fabric's comprehensive network insights are truly what make this webinar possible. So, let's acknowledge the foundation upon which we build and delve into the exciting possibilities that lie ahead. Let's start by understanding IP Fabric. IP Fabric is a powerful network assurance platform designed to collect, visualize, and comprehensively analyze large and very complex networks. It continuously gathers information from network devices and creates a very detailed and unique network model. Today's webinar explores leveraging IP Fabric's data and combining it with large language model capabilities. There are many ways to get data out of our platform. We can use a graphical user interface or API. However, traditional methods require users to know specific API queries or commands to retrieve specific properties. With an LLM, on the other hand, we can transform this experience into a simple and user-friendly interaction. Imagine asking questions in plain, human-like language and receiving contextual, precise answers. This approach simplifies data retrieval and democratizes access to network insights, making it a comfortable and easy process for anyone. We're essentially creating a network data search engine by integrating a language model with IP Fabric. Users can chat with the network data intuitively, making it accessible to those who might not be deeply familiar with the technical intricacies of network management. And as we are moving on, many different tools and frameworks are out there, but my weapon of choice is the Llama Index. It is a framework tailored for building context-augmented applications. It excels in various domains such as question-answering chatbots, document understanding and extraction, and even autonomous agents, capable of conducting research and performing actions. One of the features I started with when searching for a tool with JSON analyzing options was their JSON query engine. The idea was to use our API to extract the JSON data from the platform, feed it to the analyzer, and, well, start asking questions. Now, let's talk about the JSON query engine from Llama Index. This tool is a game changer, as it allows us to query JSON documents that adhere to a specific schema. The engine can convert natural language queries into structured queries, enabling precise data retrieval. For me, this was a significant breakthrough for the use case. I encountered a few challenges along the way, which we'll discuss shortly, but with the analyzer, I was able to create a simple, interactive prompt. With a bit of practice, I could ask meaningful questions that translated into queries and provided me with data and context. After looking for something more advanced, I decided to create a Llama app as a next step. I was greatly surprised by how easy the process was. It involves setting up your virtual environment, starting the back end and front end, and integrating your data. And trust me, if I can do it, you can do it too. The tool is designed to simplify these steps, making it accessible even to those who might not have extensive technical expertise. And I was instantly surprised by the accuracy, context, seamlessness of the whole environment. Before diving deeper, let's lighten the mood with fun facts about llamas. For example, did you know that llamas are highly social animals, often living in herds? Or due to their alert nature, they are sometimes used as guard animals. However, in our context, llama stands for Large Language Model Meta AI, which combines adaptability and intelligence in data processing. So now, let me open the code for you, and let's get started. Here's our script. It enables us to easily query and analyze structured data. The way it works is that it loads data from pre-processed JSON files and leverages a language model. In this case, we are using OpenAI's GPT 3.5 to understand questions posed in natural language. Based on the queries, it retrieves relevant information with a context. This allows us to quickly extract insights without manually parsing complex data sets or writing complex manual queries. And I have to say, the JSON query engine works great. However, to get the most out of it, you need to provide meaningful data with a corresponding scheme. The more quality content you feed the analyzer, the better context you get. In reality, I needed more time cleaning and preparing the data set than developing the code itself. I experimented with many different types. I tried a flat dataset, full JSON per device. But in the end, the one that worked the best was based on the one basic concept that is already in the platform. So here's the thing. IP Fabric splits the data into tables. The total number of all tables is about 300. Some of them are basic inventories. Some of them describe configured properties, and some describe all possible details about network protocols and their state. These tables serve as the backbone of IP Fabric's network assurance platform, offering detailed and dynamic insights into virtually any aspect of your network. To get the data more efficiently, I used our OpenAPI document and selected the number of endpoints I wanted to get the data from. I selected a variety of them, for instance, the inventories, basic address tables, some routing protocols tables, or configured time sources. Here's an example of the dataset. As you can see, I decided to use a little different table naming convention, which was not very different from the main one, but it added better context for the model. Here, you can notice that I added underscores instead of spaces, and everything is lowercase. If we look at our schema, by the way, this one was generated with Schema Builder. Here it is. So ideally, as you can imagine, all properties should be well described, providing important context to the language model. But again, the more work you put into the data description, the better results you have. So, let's see how that works. Now, here's my command line interface, and I am in my virtual environment. And let's start the Python code. Okay, that's started. So the interactive interface is ready, and we can start asking questions. Welcome to the JSON Query Analyzer. Ask your questions about your data, or type exit or quit to stop. Okay. First, I'd like to understand what network devices are in the snapshot. Let's ask our assistant if we can have a summary of the network inventory. Please, summarize the device inventory. And here's the answer. It queries the inventory dataset and tries to provide a meaningful answer. That's good. Now I see that we are using sites. Let's ask more about them. List me all site names from device inventory. And again, quick and accurate answer. So let's try something more complicated. Here's a question. List me all site names from device inventory with number of host names per each site. Okay, pretty good answer. Now we know how many host names are there per each site. And I have to say, it's accurate. Now let's imagine we need to find a specific user or server with only IP address, and we need to know where it's connected. I am searching for IPv4 endpoint with IP address 172.16.23.20. And let's see what we find out. So by providing the IP address, we have in what site it's located, what gateway it's using, and that it's physically connected to a switch on port 4. Not bad for just a query engine. What do you think? Of course, I could ask about what endpoints are connected to specific gateway or switch. I can search by VRF or MAC address. It's all going to work out well. But let's make it a bit more challenging. Let's ask a question. What is the fastest interface on a specific device? To respond to this, it needs to know where to look for the interfaces, and don't forget that it also needs to understand that device is described as host name in our data set. And as we see, the response is correct. We have the value, but we still don't know which interface has that value. But after trying to understand the issue, I found out there are multiple interfaces with the maximum value, and the engine doesn't simply understand that it should provide the interface name. To sum up my approach with the query engine, I was surprised how consistently and accurately it responds to simple queries. It can very well understand how to translate human-like questions and provide answers. Unfortunately, when it comes to more complex questions that need queries from more than one table, I couldn't get the answers. There's either a gap in my understanding of how the engine works, or it's simply beyond its capacity. Either way, it's already offering great use cases. I can imagine using it for generating contextual reports or a simple chatbot. Let's turn the page to the last chapter of our webinar, where we will discuss the Llama app. The Llama app is a different beast. With Create Llama, you can create Llama apps with absolute ease. The process involves setting up your environment and then starting the back-end, front-end, and then you just need to import your data. The tool is designed to simplify these steps, making it accessible even to those who might not have extensive technical expertise. And remember, if I can do it, you can do it too. I won't be covering the process of starting and running the app. That's out of today's scope, and trust me, there are already much better videos online. We will simply dive into results and make it less boring on the way, because this is by far the most impressive part of the webinar. So let's take a look at our chat prompt. What you can see is the Llama app front end running on my M1 laptop. Nothing fancy. If you ask me what I did to import the data, again, not much. I simply exported a bunch of CSVs from many tables and loaded them to the data folder for the backend. No API calls, no scripts. I haven't modified anything. It is important to say that it's all in default mode. Let's get into some interrogation, shall we? First test. Summarize the inventory for me, please. Great results. By the way, we are using GPT-4 for this one. We have data on sites, interfaces, and manufacturers. Okay, next one. Sounds great. Are there any issues with NTP servers? Again, excellent context. We get list of devices with NTP issues, information about sources, and as you can notice, the prompt is already more contextual than the previous one. Next, let's try some questions for dummies. Are there any security devices? And this is true. For your information, we have more than just 2 SRX devices, but most of them are in the packet mode and acting as routers, and only 2 of them are in the flow mode and are acting as firewalls. So again, precise answer. So let's get more context about them. Tell me more about these 2 devices. What do they have in common? Now you can see that the chat history is relevant as well. I am asking about these two devices, and the prompt is aware of that reference. Honestly, I just could go on, but unfortunately, the time flies like an arrow. Let me allow a few closing comments about the Llama app. To build a prototype is easy, but production is difficult. With the prototype, I used OpenAI's GPT, but we very likely prefer local AI when sharing sensitive network data. Another important aspect is the scaling and the amount of data we are processing. My network snapshot only has 50 devices. But how do we scale with a full-blown chatbot to 10,000 devices and multiple snapshots? Those are all great questions when thinking about real deployment. Apart from that, the use cases are very clear. They may include Team Support Portal, offering quick and accurate responses, greater accessibility for non-technical users, enhance the speed and accuracy of information retrieval, or to provide insights that our platform with data doesn't provide by default. And we are at the end, so let me thank you for joining us today. We hope this webinar has provided valuable insights into how you can leverage language models to interact with our network data. If you have any questions or would like to learn more, there's a Q&A right now. And wait. There's one more thing I'd like to share. In the spirit of transparency, our core value here, I'd like to be upfront about something. The audio you're hearing in this webinar is synthesized, based on a digitally cloned version of my own voice. Thank you for listening, and have a great day.